So this is the Unit 3 test review worksheet dealing with quadratics for Algebra 2. And so I'm going to walk through all the steps like you should do as well, just like it was taught in the Michigan Virtual class as well as our Zoom classes. So starting with the first one with 3.1, when we were factoring each equation, the way I was teaching it was to make those little X's to fill out the top and then the bottom. So you have negative 18 on the top, negative 7 on the bottom, and you are thinking of two numbers that multiply to get to negative 18 but add to get to negative 7. So if you list out your factors for negative 18, we have 1 and 18 and 2 and 9, also 3 and 6. So 2 and 9 are 7 units apart. So if we can take 2 and negative 9, we can add those together to get negative 7. So when I write my factors, because it just says to factor each equation, it does not say to solve it, we would just write them into our two factors like this. And it's called intercept form, and we put x's in the front of both because we have to get to x squared, and then a minus 9 for one and a plus 2 for the other. And it does not matter the order here. I could have switched these around, but that's the final answer there. You don't do anything else. If you had to solve it, you would set them equal to 0 and solve. But the question just says to factor it, so that's what we do. Another one, same idea. We have negative 14 on the top and negative 5 on the bottom. And so the two numbers that multiply to get to negative 14 but add to get to negative 5 would be 7 and 2, because obviously 1 and 14, but that won't get you to negative 5. So 7 and 2, I could make a negative 7 and a positive 2 to add them together to get to negative 5. And then again, I go to my two parentheses, this time with p's, and put p minus 7 for one and p plus 2 for the other. And again, it doesn't matter the order. You could have switched those around. All right, then we have our last one here. Now this has a 2 in front of it, an a value. And so when that happens, you would first check, can I divide everything through by that same number or a different number? And no, they are not all divisible by 2. So there's no GCF there. So instead, when you go to do your little x here, we would multiply the first and the last numbers together to get 42. And then the bottom number is still 17. So this time you would ask yourself what two numbers multiply to get you to 42, but add to get to 17. And I did show you guys there's a trick in the calculator, the graphing calculator. If you go to the y equals and type in 42 divided by x, in this case the top number divided by x, and then go to table, you can then find all the numbers that are factors of 42. And specifically, I want to stay in the positives because I'm trying to get to a positive 17, and 42 is also positive. So I'm thinking of two numbers here that when I add them up, I get to 17, which I see 3 and 14 right here. So I'm going to go ahead and put those 3 and 14, because when I add them together, I'd get 17. They obviously multiply to get 42. And so here I would either use the box method, I could do factor by grouping, if you are using this method. Now guess and check is another option where you just guess what goes in the, it's not too difficult here because it's a 2b squared. You could just figure out the 2b and the b for like the front parts and then figure out what two numbers for the end to get to 21. So that part's not too bad either. If you are using the box method, which for those of you that need a little more support, this is what you should start with. You fill the box in inside of it. So you put 2b squared and that 21 on the bottom right corner. Then for the other two terms, like your diagonal, you grab the 3 and the 14 that we just came up with, and we write them with b's. So 3b and 14b, whichever place you put it. Then we start taking some GCF. So the first row is just a b. Now 2, because 2 and 3 had nothing in common, that's why I didn't factor out a number with b. But the top column here would be 2b, because I have 2b squared and 14b that I want to take the GCF out of. Then same for 3b and 21, I could take out a 3, positive 3, so I put a plus sign with it. And finally, for that last row, 14b and 21 have a 7 in common. So when I'm all set now, I've figured out all the sides here. I now write them in their two parentheses, and I'm done. So here are these are the factors, or this is factored form for this equation. So this was all from 3.1 when we got to factoring quadratics. Now on to writing equations in vertex form. So just a recap, vertex form looks like this. Y equals a times x minus h squared plus k. And we look at where is the vertex, right here. It does give us a hint, says that a is equal to 1 because we haven't really practiced too much of how you know when a can change. So we just need to identify that point, which is sitting at -3, -1. And it is upside down, so although it says a is equal to 1, it's technically a negative. So I'm going to just sneak a negative right next to that so that when I write my equation, although a might be 1 as far as like you call it, like it's not a slope, but it's like telling you how much it's changing, like a second difference. Since a is 1, it's kind of going down 1, right 1, down 1, left 1, but I do need to put a -1, not just a 1, because I have it upside down here. Then for my h and k, which were -3 and -1, I have to tell my graph to go left 3. So that's where you put the opposite sign here for h, and then down 1. So that would be the equation in vertex form. That's all you do for that. Same thing on the next one, except when you're given information, you're just plugging it right into the equation. So this time, that 1 for a, you don't have to write it in. Same thing here, I could have just put a negative, but we can also write it like I did. X plus 2, again, switch that sign, squared, and then a plus 5. So that's all we'd have to do on this one. No real work to these because you're just plugging a, h, and k right into the equation. Now the next one says, how do you determine if a parabola has a minimum point or a maximum point? And can a parabola have both? And we have to explain why. So to determine a min or a max, and this was a question that was on the I believe it's 3.2 quiz. To determine that, you have to look at the a value. Remember, if the a value is greater than 0, that means it's positive. If the a value is positive, that means then that you have a minimum, because the graph would be opening up like this, where you'd have the lowest point would be the vertex. Okay, I didn't write a ton down as far as words. You can definitely write this kind of in more complete sentences, but I'm just kind of giving the gist of it here. If the a value, though, is less than 0, which means it's a negative number, then it would be a maximum, because the graph would turn upside down like this, where now the vertex would be at the top, the highest point, and you would then have to figure out what the min or the max are. To do that, you would look at the y value of the vertex. So no, a parabola can't have both. To explain further, it's because it has to do with the a value. The a value can either be positive or negative. It can't be both. So never will it be possible to have both a minimum or and a maximum. It's got to be one or the other. It obviously has to be one or the other. If a happened to be 0, then you no longer have a quadratic. So it has to either be a positive number or a negative number to help you decide which one. And then once you know what it is, you can then find the answer. All right, so for the next few, for number 7 and 8, it says to use the quadratic formula. It says give the exact answer, no decimals. It says use simplified radical form as needed. I'm actually going to alter these directions just a little bit because I'd actually rather you guys do decimals because of Michigan Virtual, the way that the test questions are. They don't do simplified radical form. It is important, though, to know how to do all of this because, again, for moving on in pre-calc and stuff, you will need to eventually know it. But for this class, specifically for the unit test, you do want to leave it as decimals. So decimals are okay here. So if I'm trying to solve this using quadratic formula, here is the formula. So we can start with that. Negative b plus or minus square root b squared minus 4ac all over 2a. So this was from 3.4 that we did on Monday. So this Monday or Tuesday, depending on your hour. So we're gonna go ahead and plug the numbers right in. So a is 1, there's no number in front of m squared, b is -5, and c is -14. So let's see what this comes out to, plugging in the numbers. Now -5, but goes in for negative b, would then be a +5, plus or minus the square root of -5 would go in parentheses, because I'm going to square it, and then -4 A is 1, and C is negative 14. All divided by 2 times 1. So we're going to simplify until we can go to a calculator and then just get a decimal answer. So at this point is where I grab a calculator and I type this whole thing that's in the radical, but not including the radical, just everything that's inside of it. So starting with the negative 5 in parentheses squared, then we have minus 4 times 1 times negative 14. And then, oops, I don't want to graph it. And hit enter, and this is 81. So I'm getting 81 for this, which happens to be a perfect square. So this one actually could have been factored, and you can always check a question first and see if it's factorable because it might be quicker. But obviously on the test, you could kind of go about it either way then, because it is multiple choice for the most part, unless you need to show your steps. So 5 plus or minus 9 equals 2. I would split that up into 2. I either have 5 plus 9 divided by 2 as one answer, or 5 minus 9 divided by 2 as another. 5 plus 9 is 14, and when I divide it by 2, I get 7. There's one answer. Same idea here. 5 minus 9 is negative 4. When I divide it by 2, I get negative 2. So those are my two answers. Those are my x-intercepts. I can leave them like this, but it is actually better to write them as ordered pairs, like this. But I believe Michigan Virtual will leave the answers just as the numbers. All right, same idea on this next one, except first you're going to add 10 to start because we need to move everything to one side. So 2m squared minus 7m minus 3 equals 0. Get right to substituting everything in to get your everything into quadratic formula. So a is 2, b is negative 7, and c is negative 3. So negative b this time again would be a positive 7, because I'm changing the negative 7 sign because I'm plugging it right here into this negative b. So positive 7 plus or minus negative 7 squared in parentheses minus 4 times 2 times negative 3. All divided by 2 times 2. All right, and then we're going to keep solving here, or just simplifying. 7 plus or minus, again, I would grab my calculator to help here. So I have negative 7 in parentheses squared minus 4 times 2 times negative 3. Comes out to 73, and that is not a perfect square. So we are going to need to put write it as a decimal. So here's where you would grab the calculator again, because we have two answers here. We need to do 7 plus root 73, or radical 73, and then divide that by 4. So one of my answers, I'll actually just write it down here, x, and we're rounding it, so it's better to put those little approximation squigglies, 3.886. And then if I was to do 7 minus square root of 73 and divide that answer by 4, I would get negative 0.386. So those are my two answers, rounded to 3 numbers after the decimal, because that's how Michigan Virtual will be leaving those answers as well. All right, and we'll go ahead and keep going here. Okay, number 9 and 10, same idea. We're just using same with the more with quadratics, but completing the square this time. And it again says not to give decimals, and it does say to solve this, but actually, you know what? There is no solving. We're gonna actually skip this whole section up here because there are no solving questions with completing the square on the test. So I'd rather you focus on the ones that are on there, which will be 11 through 13. So let's go down here. And to start off with completing the square where you're trying to convert it into vertex form, we did all the problems the same way, where I started with adding the C value to the other side. Now you could choose to follow the directions that Michigan Virtual had, which were slightly different, but you'd get the same answer. So decide which way, whatever makes sense to you. So here is what I have so far. I started off by just adding my C value to the other side so I could kind of move that over. Now you would take the GCF of the first two terms, which in this case is a negative 3, leaving me with x squared and a minus 8x. I'm going to leave the left-hand side the same for now, but I do need to add something to the end of this, and that something is where you take negative 8, you divide it in half, or you divide it by 2, and you square it. So negative 8 divided by 2 is negative 4. When I square that, I get 16. But I'm not just adding 16 to one side and then not doing anything to the other because that would not be balanced. So here's where I would take my calculator and multiply 16 times negative 3, which is negative 48, and I would have to add to the other side because that balances the equation. So now on the left-hand side, I have 27 minus 48 here, which is going to be y minus 21 is equal to negative 3, and now I have to factor this guy. So this is a perfect square trinomial. I have to take the square root of 16, which is 4, and I would put a minus sign instead of a plus because of that negative 8. So this is how you write it as a simplified, it's called a binomial squared. Anytime you have a perfect square trinomial, we go right to this. And we're almost done with completing the square now. We just add 21 back to the other side. Now it's 21, not what we started off with, because then it's now in vertex form. That's your k value. So we have our a, h, and k all filled in to our vertex form, and that's the final answer. So you're going to do that kind of for the next few examples, always doing the same thing to start. I'm always going to start with subtracting that, adding or subtracting that c value. So we have that over to the other side, and we don't have to kind of bother with it right now. You could, again, decide to do it the other way that Michigan Virtual explained, which is similar, it just kind of keeps everything on one side. So here I'm dividing everything by, factoring everything out by 2. Oops. I don't want to close that parentheses actually, because I'm going to add something to the end of it. And that something, again, you take negative 2, divide it by 2, and square it. So negative 2 divided by 2 is negative 1. Squared is just 1. So I'm adding 1 to this side, but that means I need to add 2 to the left side because it's 2 times 1. And now I have y minus 3 is equal to 2 minus 1 squared. Because again, you take the, you're factoring this perfect square trinomial by taking the square root of the 1 and keeping the sign of the middle term. And that's what it looks like. And we're almost done again. Just add 3. So y equals 2 x minus 1 squared plus 3. All right, there's one more, and now finally the last one, you're going to again start by adding 1, y plus 1 equals 3x squared plus 2x. Actually, I'm sorry, this one doesn't have a common number. We're not going to have any that are decimals or any kind of fractions like that. So you can actually skip number 13 as well. All right, any questions? If you do have questions on these, please make sure you're coming in for some extra help in the afternoons. I'd be happy to help you between anytime this week before you take that test on Friday. All right, numbers 14 and 15, we are working with transformations, kind of talking about how to graph these, and then giving a quick description of the transformation. That's going to be like using RST is the best way to look at that. So like for this one, without even having graphed it, I know there's a reflection because it's got a negative in front for the a value. Then when I cover up the negative, 2 tells me that this is a stretch, vertical stretch. Those are the only kinds we work with here. And then to do the translation, you go in the opposite direction for the h, which would be left 5, and then you go up or down for the k, which is up 3. So that's my RST for this, and I'll go ahead and graph it now because my vertex is negative 5, 3. So you're going to plot your point at negative 5 and then up 3. And then the easiest way to plot a few more points here is to take that a value, which is negative 2, and kind of treat it as a slope where you go down 2 and right 1 and down 2 and left 1. You don't have to, it's obviously not a slope though, so make sure you know that you can't just keep doing that because then that would be linear on both sides, which is actually absolute value, which is not the case here. Instead, you want to figure out what would the next point be that you could plot. So for example, I could figure out what happens at negative 3 or what happens at negative 7 by just plugging a number in. I could also find the y-intercept, which is the way that Michigan Virtual had you guys practicing it. A y-intercept would be when x is 0. So if I did that, I could plug 0 in, and I would solve for it until I find out what y is. So this would be negative 2 times 25, because 0 plus 5 is 5, squared plus 3. This is negative 75 plus 3. As you can see, it does not fit on my graph. So sometimes I talked about this in class, the y-intercept is not very helpful. Now the x-intercept you could try to solve for, but even then you might end up with fractions or decimals sometimes, and so that might not be the most helpful way to find the answer, though you could figure out where that is, but this is good enough kind of just to get the idea that this is my parabola. It's not going to hit right at the next spot. We can figure out what happens at -3 or at -7, kind of how far down it goes, but you don't have to go that far. All right, same idea for this one. The most important part is, can you figure out your vertex and plot it? So this vertex is 3, -5, and then use the a value to help you kind of draw out the shape of the parabola. So this one, 3, and then down at -5, right here. This time the a value is 1/4, so you could go up 1 and right 4, and that's a great way to get the graph, and also left up 1 and left 4. So it's a pretty wide graph here, but it's not a V, it is a U shape like this. And you could, again, to get more of an accurate graph, you would then have to figure out what happens at like 5 and substitute it in. Or you could find the y-intercept if you'd rather do that, but it would be a decimal. So again, sometimes finding more points is not more helpful. You have to be smart about which kind of points you want. You might want to find the x-intercepts here. To do that, you could plug 0 in for y and then solve, but again, they could be decimals. So as long as you have the idea, because these are going to be your multiple choice questions, that as long as you know that it's opening up, it's a wide graph like this because of the a value, and you know what the vertex is, then you should be pretty good on this. And then don't forget, we do draw AOS here. At least we do in our usual math classes. I don't know if Michigan Virtual always does, but we should draw in the axis of symmetry on those. And then the RST this time, no reflection because the a value is positive. It's opening up. There is a shrink though. It's a vertical shrink because 1/4 is a number between 0 and 1. And then we go right 3 and down 5. All right, let's go through our last page here. And again, all of this will be posted for the answer key. All right, so on this next one, we're now working on those applications that we just did. So hopefully you finish that last section, 3.5, before you get to the test. It says Abraham throws a ball from a point 40 meters above the ground. The height of the ball from the ground after t seconds is defined by the function. So they give us the equation to work with. If it's saying how long will it take the ball to hit the ground is at 0 for the height for h. So we're going to substitute 0 in for our h of t here. And here's the rest of the equation. You can now solve this equation to find what t is, because we're trying to see how long does it take, and it says show work. So to solve this, we have a couple of different ways. Well, what would help is if you kind of change the order here, because we can either use quadratic formula, you could use completing the square, or we could try to factor it. So you pretty much have all 3 of your options to work with. But I'm going to just switch this around because it'll be maybe a little bit easier to see once it's switched around like this. So the best way, or the quickest way to me, is factoring it, finding the GCF, greatest common factor. They both have a 5 in common. So 5 and 40 both have that in common, plus the first term is a negative. So you do have to keep it negative then. So when I factor out a -5, you're basically dividing -5. Now, if you would rather just solve by dividing, you don't have to write the number in front. We could just say 0 equals t squared minus 8t, like that. And actually, before I finish here, though, I do have one more thing I could, instead of just dividing by -5, I cannot divide by t. What I can do, however, though, is factor out a t. So if I was to factor a t out of this, here's what it would look like. T taken out, and I'm left with t minus 8. At that point, I would set them both equal to 0 and solve whichever one needed to be solved, which is this one here, getting t all by itself, and you find out that t is 8, t is also 0, but here it doesn't make sense for it to hit the ground after 0 seconds if it's never actually gone up into the air. So this is the 0 seconds before it starts. This is the 8 seconds after. So we're not using that answer. Instead, we're just going to say 8 seconds. So that is the final answer for how long it took to hit the ground. Now you could have again used completing the square, but we haven't done that really with solving too much, and then you could have used quadratic formula instead as well, because again you had to just show work for whichever way you went about it. All right, here's another one. You are trying to dunk a basketball. You need 2.5 feet in the air to dunk the ball. The height of the that your feet are above the ground is given by this equation. And what's the maximum height your feet will feel above the ground, or your feet will be above the ground? Will you be able to dunk the basketball? So in order to find the maximum, you are actually working with a formula to help you kind of get to that maximum, which is the y value of the vertex. Well, in order to find the y value of the vertex, we need the x value of the vertex. So we're going to use this equation, negative b over 2a, where it's just like the same a and b that are in standard form. And then we're going to go ahead and substitute the numbers in. So negative 12 over 2 times negative 16 would be negative 12 over negative 32. And you can write this as a decimal because that's the x value of the vertex, and then we'll find the y value after that. So this comes out to 0.375. That's how long it would take to get to the maximum. And so it says here that we're going to go ahead and now find the maximum by using this x value. So we're going to substitute it in. It's actually t, it's not x, but you can use either variable. So now to find the x value here, or this technically this is the t value, we're substituting in 0.375 everywhere you see a t, and grabbing a calculator to help you with this. So it's negative 16. So what's that? Negative 16 in parentheses 0.375 squared plus 12 times 0.375. And that comes out to 2.25. So according to this, because this is in seconds, I think it said seconds. Actually, it doesn't specify, but I'm guessing it's seconds. 2.25 feet is how far high up you'd go. So if you kind of imagine the maximum here, it's saying that if you were to start, you kind of go up in the air and then you come back down. It's saying that this height here, the highest you could go for the y value would be 2.25. But it said you need to jump 2.5 feet up in the air to dunk the ball. You're a little short. You're at 2.25 feet, not quite 2.5 feet. So when it says, will you be able to dunk the basketball? No, you need 0.25 more feet. Right, because you could only make it to 2.25 at most, and I need to get up to 2.5 in order to get to dunk the ball. All right, so that's a little bit with working with quadratics. The last part here works with the discriminant, and then we'll finish up with the last one. So the next two, dealing with discriminants, b squared minus 4ac, determining the number and type of solution once you get what the discriminant is. So remember, use that to plug the numbers in. A is 6, b is negative 2, c is negative 3. So we have b squared would be negative 2 squared minus 4 times 6 times negative 3. You can use your calculator to figure out the answer for this. So we have negative 2 squared minus 4 times 6 times negative 3. And that comes out to 76. Now, since 76 is a positive number, that means I will get two solutions. Now, we didn't really talk too much about real or imaginary. Technically, this would be real solutions. That's what it means by type. You don't have to worry about this for the quiz, though. You just can say how many. All right, and so if you kind of imagine a graph here, it would hit twice to something like this, if that's what the graph was. And finally, this last one, that's the discriminant. You first want to move everything to one side because you can't use the discriminant equation until then. So we have negative 9b squared plus 8b minus 8. I could have also actually moved the 9b squared to the other side. It doesn't matter which one you did because any way you do it, you'd get the same answer. So b squared minus 4ac, 8 squared minus 4 times negative 9 times negative 8. You could put the b in parentheses if you'd like. And again, grab a calculator to see what this comes out to. So 8 squared, or you could just get right to 64, either way, minus 4 times negative 9 times negative 8. Comes out to a negative 224. So this time it is negative. And so whenever it's a negative discriminant, then we know that it's going to have 0 solutions or no solution. You can say it either way, but it is 0 because it's not possible to take the square root of a negative number. And so we talk about how this is called 0 real solutions. Later on, you'll definitely learn more with that because Michigan Virtual did not explain that too much. All right. Again, if you have questions on these, I'd be happy to help you with them in more detail, just coming in the afternoons any day. The last one says a plot of land has for sale has a width of X feet and a length that is 8 feet less than its width. So if I kind of imagine this rectangle here, I have X feet for the width, and if it's 8 feet less than the width, I'm going to take 8 away from X, like that. A farmer will only purchase the land if it measures 240 square feet. So to find square feet, or like the area of this, we would have to multiply the length and the width together, and it's saying here that it would have to equal 240 because that's the square footage, that's your area. What value of X will cause the farmer to purchase land? So we're solving for X here until you find out what X is. So we're gonna first start off by distributing the X. So you get X squared minus 8X equals 240. Now I would move the 240 over because you're trying to figure out what is X. So X squared minus 8X minus 240 equals 0. You can now use either quadratic formula, or if it happened to factor, you could try factoring. I'm not sure if it does. You could even use completing the square, but I'm going to go ahead and just use quadratic formula since that one is kind of a guaranteed. It always works anytime you have a standard form equation like this. So negative b would be a positive 8. Positive 8 plus or minus square root of negative 8 squared minus 4 times 1 times, this is negative 240. Sorry, it's tiny. And then all over 2 times 1. And definitely use the calculator to help. 8 plus or minus, again, we'll get the square root to show us what's inside there. Negative 8 squared minus 4 times 1 times negative 240. Comes out to 1024, which I believe is a perfect square. So let's check. It is 32. So this one probably could have been factored, but we didn't know that right away. So then divided by 2, here's what I have so far. 8 plus or minus 32 divided by 2. So we're going to get 2 answers here. But one of them may not work because we're saying what value of X would work. We can't have negative values for X because we're talking about a piece of a distance or a length or width of feet. Can't have negative ones of those. So 8 plus 32 would be 40. Divided that by 2, we get 20. And here's the one that doesn't work. 8 minus 32 would give me a negative number, and then dividing it by 2 would still keep it negative. So I'm not going to bother finding that second one. You could find it if you're not sure until you do. But the final answer here would be 20 feet will be like the value of X. And once I know that, then I could technically know what the length and the width are, so that this would be true for that. So, but the question just said what value of X would work, and that would be 20. All right, and that's pretty much it. Again, this answer key is posted on the teacher feed so that you can also, if at any point you miss something, it's all there for you.